It's really material in your waste, all the microbes that come out of your body, so all the bacteria that live in your guts, about half the volume in your gut is microbial, not your own. So a lot of that stuff goes into the waste. Skin cells, nail clippings, hair, scabs, I guess? I don't know. Very small grit will settle, and that's called sludge. Now, here's the funny thing. Sludge, in most parts of the world, can be used as fertilizer. It's called night soil, and actually, if you look at the composition of what I put on here, that's actually like pretty good dirt. You got some sand and some grit and some carbon and some nitrogen. That is actually like a really good compost mix. Night soil is poo sludge fertilizer, but you can't use it in the United States. Anybody know why? Yeah, because of our wacky diet, all of our prescription medicines cannot be treated out of this. So antidepressants, for some reason, survive your digestive system very well. Birth control and hormone therapy survive your system very well. And also, all those heavy metals from that spectacular seafood that we get to eat, a lot of that makes it out of our system. And it turns sludge into toxic waste. So in most parts of the world, and when even in the U.S. we had a slightly more primitive chemical landscape, our poo sludge fertilizer, aka night soil, was an awesome soil additive. In the last, I'd say 30 to 40 years, it's become increasingly hazardous to use. Most parts of the United States now just landfill, or in some cases they surface apply, but usually landfill the sludge the last 20 or 30 years.
So it's just a nice not growing in it, or
I actually think that the plants would grow in it just fine as far as I understand the issue. But actually the runoff of those farms, it's not that the plants would necessarily absorb them, they might, but we know that they're water soluble, that's how they get into us, and so they run off. The big impact is you can have agents that are hormonally active in amphibians and fish, and of course you can have the heavy metals accumulating in our food web. Okay, so that's primary treatment. All wastewater management has some sort of solid removal. And remember, I don't mean solids like Duraflame laws. I mean solids like small stuff that probably makes it into and out of your drains. The second step is a chemical digestion of waste. This is the same type that we talked about here. Most of your waste is biodegradable. How shall we address this, do you think? I know, you look sorry, and I believe that you are. You're a really nice girl, but what are we gonna do about this?
I'm setting a reminder to look up the filter sheet.
That's good, yes. It's a good idea to have a reminder. Can you set a reminder not to use your cell phone?
I probably can do that.
Good, do that. Okay. Secondary treatment is chemical, and by chemical I actually mean biochemical. So that's digestion by microbes that break down the organic compounds in the waters. So that would be fat, sugar, carbs, protein, soap. What else would end up in there? Like, I guess alcohol probably breaks down. I don't really know what else ends up in the wastewater, but this is
alcohol dissolved.
Yeah, right. So these are the organic compounds that can still be identified in water. There's usually some microbe that will eat those. Now, you break those up into simpler chemical building blocks like carbon, nitrogen, phosphorus, potassium compounds, usually as oxides. This requires oxygen, you know that. So this is where the aeration tanks are. You give air to the microbes that digest the stuff you didn't get to use. Yeah.
You know how we talked about anaerobic digestion, where it creates methane?
Yeah.
Could you use that to like make natural gas?
Right there. They do, and they make natural gas, and they run the generators at the wastewater treatment facility with the parts that haven't happened in you yet.
What is the potential to make that a larger scale development?
Limitless, because it's already in one place, and usually it pays for itself in a couple of years, so many cities are doing this.
People already power it.
There's differing degrees of efficiency that are inherent to the plumbing and the scale of production and the temperatures actually makes a huge difference. So some parts of the world where it just gets too cold, the digestion doesn't happen because anaerobic bacteria are usually down for your gut and your gut is usually warm.
Like, there's just so much waste,
Yes.
and landfills
Yes.
too could be.
Both of those are increasingly becoming reliable sources of natural gas throughout the U.S. and the developed world. One thing I have to tell you about is that these microbes come from your gut. They keep doing the same type of digestion. So this is the real high stakes part of wastewater treatment. At the wastewater treatment facility, there's like engineers and plumbers that work out like the pipe goes here and the overflow and the air venting and the mixing of the infusion of the Bernoulli protein skimming Venturi effect thing. And then there's a whole crew of staff at the wastewater treatment facility that does nothing but maintain the microbes. Here's a funny detail, for example. Does everybody realize that most of the biological content in wastewater is added in the morning? Between like 6:30 and 7:45, I'm sure you can imagine that's when almost all of us flush the drain in the morning. So the wastewater treatment facility has a regular full day supply of sinks and showers and bathtubs, but the toilets, especially with the poo, that all comes in the morning. So they will spend all day today culturing a giant population of bacteria so that those bacteria are starving and overpopulated by tomorrow at 7:30, when all your poos reach those tanks and start feeding those bacteria. Then by 11 or 12, they'll be done. That water will go out to the ocean. And from noon until the following day, they'll start stashing a few bacteria from each flush into these giant tanks, feed them just a little, get their population levels up so that those bacteria are ready to work again the following morning. I actually was really pleasantly surprised that it's so much of a biological, organic interaction. I had this idea of like add a drop of this, add a drop of that, and press a blender, mix up a little. But it's all just maintaining a culture of your gut bacteria to keep doing that digestion. Yeah.
You know how big is the culture?
The culture is massive. They have, I believe, 40 tanks, and each of them is roughly half this roof, stacked about 10 feet deep. And you can see it for yourself. It's like a landscape of deep water that's all super aerated. That's why they're the biggest electricity user in the county. It's for all the pumps to push the air into that much water.
Do you know, like, the approximate lag time for flushing the toilet, reaching there? Cause, like,
They know precisely.
But I'm guessing they don't get it at 7:30. I'm guessing it's more like 9.
Exactly. Whatever that timing is, they know. But I don't. We can ask the people there.
Oh, I know that.
Okay.
How long does it take for water to get all the way through flushing the
So their throughput, again, is largely temperature dependent. And by the way, some of these bacteria depend on sunlight or on darkness, so there's seasonal adjustments for temperature and ultraviolet intensity. They know that too. It's called a throughput rate. I believe their throughput rate on average yearly is about 16 hours. So a molecule of water will enter and leave it in 16 hours. Now, please look up. You can imagine that secondary outflow is basically fertilizer water, right? In some cases, if you put fertilizer into the water, you understand the problem, right? First, the fertilizer makes an algae bloom. That's extra productivity, extra life. Everybody's happy. It's a party. That's not a problem. But when those nutrients run out, the algae dies, and now you have biodegradable waste. The decomposition of the algae creates a dead zone. Understand this? Everybody's clear with all this? The algae bloom is not the problem. It's the dying of the algae bloom. So to prevent this, many places will uptake those nutrients, get rid of the nutrients so that you don't get eutrophication. And you can do this in 4 major ways. In some places, you chemically treat it. You bond it and bond it and bond it again to make large inorganic compounds. This is very expensive and very rare, only in really crowded urban areas without a good outlet for the water. Some parts of the Middle East, some parts of Asia, some parts of Europe do this part.
Any parts of America?
Probably, but I don't know enough off my head. Many parts will use plants. Like, anybody know if they have a septic system at their house? Yeah. Like my dome has a septic system, and there you just get rid of this nutrient water into the roots of plants. And the plants are like, thank you, fertilizer, they make biomass, and your groundwater leaves clear. No problem. There are some places where you can feed those nutrients into a wetland. How many of you know Humboldt State University, a city called Arcata, Northern California? So Arcata is an agricultural area. Humboldt Bay used to receive giant volumes of coastal runoff from all those headwaters and redwoods. But I'm sure you all understand that water is now increasingly diverted to agriculture and ranching, increasingly polluted from all the logging, all the erosion of those clear cuts, all the random chemicals used by the pot industry that's so massive out there, and of course all the urban runoff from those cities. So, in Arcata, their coastal wetlands have been dried out and polluted. Until the 1980s, some nerd up there said, hey, wait a minute, with our growing population, we've got all the secondary outflow. Let's just feed it into the wetlands. Remember, wetlands are ecologically designed for nutrient-rich water. So in Arcata, they fertilized one of the world's most successful bird refuges with their secondary outflow. And you guys know what we do with it in Santa Barbara? Nothing at all. We just throw it out in the ocean. We don't need tertiary treatment because our ocean is super productive. You know that we have kelp intertidal here? And it's also super active. Our ocean moves the water really quickly. So in Santa Barbara, we just skip nutrient. We don't do tertiary treatment. We feed secondary outflow straight to the ocean. There's enough current that those nutrients get distributed in oxygen-rich water anyway. It's not a big whoop. Remember, if you don't do this, you've got nutrient-rich water, and if that gets into surface waters, that can cause eutrophication. One other thing, this is cool about Santa Barbara. if any secondary or tertiary outflow is gonna go to public supply, however it leaves the system, it's usually sterilized with chlorine or ozone or ultraviolet or other stuff I don't know.